Hello everyone, let's find out an expression for equivalent spring constant in case of springs in series and springs in parallel. We'll take the first case where we have springs in series. In this case, we have taken two springs. The same thing could be extended to other springs also, but the most simplest case would be to take two springs. As shown here, we're taking two springs of spring constants K1 and K2 to which a mass is attached. Now because of the mass attached, the whole thing would expand. Imagine that after the mass is attached and left, the system would have an extension because of which the mass comes somewhere here. So the whole system is extended by some distance x as given here. Spring constant is K1 for this, it's K2 for this. Now in this case, if we try to replace these two by a single spring, so that even that single spring, which when present here, will have extension of same thing only. Which means when put the same mass m to the single system called as K suffix s, even this will have the same extension x only. So in this case, we can say that the extension x is equal to, that is x is equal to, both the springs would extend, that is equal to x1 plus x2, that is the extension in a single spring is same as the extension in both the springs together. But we know that the restoring force is equal to minus k into x, but the restoring force is same as applied force in magnitude. Therefore, we can say applied force is equal to k into x in terms of magnitude. In this case, the mass is only the weight attached here, and since the springs are assumed to be massless, then the same force acts to both K1 K2. Therefore, what you can say here is, we can say it becomes F by K1 plus F by K2, because here the same force acts. From here we get K is equal to F by X. For the equivalent spring, the force is still same only because it is the same mass attached to the spring. It becomes F by K suffix S. From here F gets cancelled. Therefore we can say that 1 by K suffix S is equal to 1 by K1 plus 1 by K2. If you have more number of springs, you can extend the same argument for the springs also. So this is the equivalent spring constant for two springs in series. You can say that the reciprocal of the equivalent spring constant is equal to sum of reciprocal of individual spring constants. Let's find out what is the expression for equivalent springs in parallel now. As shown diagram, there are two springs with spring constants K1 and K2 to which a mass m is attached. Now before the mass is attached, the springs would have some kind of a presence like this. Once the mass is attached, they will extend together. Let's assume that the springs extend from this configuration, from here to something of this configuration. So once the mass is left free, the mass would come to this configuration, which means both the springs would extend by same amount in this case. Now here we'll find its equivalent spring constant, which means we'll have one more spring where we had a mass like this, and if this mass was left, that is if the finger is removed behind the mass, then this spring would also extend to this amount, which means in this case, for a given mass m attached, both K1, K2, that is both the springs, would have the same extension as that of equivalent spring. So this is the equivalent spring. But in this case, the force is mg, but this force divides two parts. A part of the force goes into this and a part goes into this, which means we can say the force acts in this case, this force is mg. Now the same force when acting on the two springs would spread, would divide. It becomes F1 plus F2. For example, imagine that the force acting here is that the mass is say 1 kg and g is equal to 10 meter per second square. So the force in this case would be 10 Newton, and also the force here would be 10 Newton only. Now this 10 Newton acts completely only one spring, but here this 10 Newton divides into two parts. The parts could be equal or unequal depending on spring constants. So wrote here, you can say that the force acting in case of a single spring, that is 10 Newton, spreads between two objects. For example, say 6 Newton may act on this and 4 may act on this. Don't by have these numbers. I just think of to understand the concept. But force would cross an extension spring. You can say K parallel into X is equal to K1 into X plus K2 into X. From here, X gets cancelled. Therefore, what you get from here is the equivalent spring constant in case of parallel combination is equal to sum of individual spring constants. If you have more than two springs, just extend it by adding the spring constant. So this is the expression for equivalent spring constants. The springs are in parallel.